Hi, everyone. My name is Przemek, and this is a joint effort with Augusto, who unfortunately wasn't able to come to the Airflow Summit in person. And we also have Michal, who's going to help with the talk. And this is a talk about scaling Airflow, Airflow 3 in particular, and the testing framework, performance testing framework we are currently working on. So, my name is Przemek. I've been a software engineer at Google since 2011 and in Cloud Composer since 2019. And in my previous life, I did a PhD at Warsaw University of Technology. And this is Michal.
Hey, great to be here and nice to meet you again this year. I'm engineering manager in Cloud Composer since 2022. And I'm also a member of the Airflow Summit organizational committee.
Okay, so in this talk, we're going to show you the performance testing framework we are working on, and also some results, especially looking at comparing Airflow 3 to Airflow 2. And also looking at tweaking some parameters, changing some configuration to see what happens with performance. And in the end, we'll finish with some conclusions. So let's start with the performance framework. What are the goals of the framework? The immediate goals now were to compare Airflow 3 and Airflow 2 to see how Airflow 3 performs, given that there's major changes in Airflow 3. And also we're looking at testing the scaling limits, how much can Airflow handle in terms of the number of tasks. And looking at the framework itself, we want to make the tests easy to run, easy to change configuration, make multiple configurations, run the tests multiple times, get reproducible results so that we can compare, for example, new releases of Airflow, new code of Airflow, how it performs. And in the ideal future, we'd like to continuously run the performance tests to see how performance changes, whether code changes, any new additions improved the performance, maybe either improve or decrease the performance. So the whole effort of the performance framework started with an AIP, and now I'll hand it over to Michal to talk about the AIP history.
Yeah, so a little bit of history. Even before Airflow 3, that was at times of, Airflow 2.3 or 2.4, we realized with subsequent Airflow releases in Composer that new Airflow versions, however richer in features, they also tend to consume more resources. And that can mean various things. It can mean that some components like workers or schedulers need more memory. That could mean that latencies of some operations within Airflow were higher, and without a repeatable process and benchmark, we were sort of driving blind with new Airflow version that was released and then later onboarded in our service. So at that time, we proposed a new AIP, AIP 59, to introduce this test performance benchmark framework to, on one hand, test the performance of particular components to collect metrics about CPU or memory consumption of different components in Airflow, with the idea that this can be used to detect performance changes between Airflow versions. But even more, if run continuously, it could be detected to detect these changes even before the Airflow versions are shipped, presumably identifying some faulty changes or maybe features that were enabled or introduced that consume more resources. Airflow can be deployed in many ways. We deploy it in some specific setup in Composer, but many people do it in their own deployments. And this can vary a lot, and this can have impact on how the Airflow components perform and where your performance bottlenecks are. So the idea of the framework was to deliver something that's open source, anyone can take from the Airflow repository and tune towards their deployment and use it in a repeatable way, not just on vanilla Airflow in community, but also take it and run it in your particular deployment of Airflow. Spoiler, we do use this framework internally in Composer, and we wanted to give it to community as well, so anyone can do so.
Okay, thank you. So let's now dive into the framework itself, starting with some concepts we're going to talk about. So firstly, there's the instance. So this is the definition of the Airflow installation, how Airflow is set up, where it is run, how it is configured. So this is how we run Airflow. Then the second point is performance DAG. So we define what kind of DAG we run, or multiple DAGs, how they're executed, what the DAGs do, how many tasks they have, what are the relationships between tasks. And those two combined together give us a test suite, which is a combination of the instance and the performance DAG. And this is the unit of running a test. So what goes into the configuration of an instance? First of all, we configure the instance type. So where do we run Airflow? Is it Docker Compose? Is it Kubernetes? Is it Kubernetes run locally, or is it run somewhere on the cloud in one of the cloud providers? Maybe it's the Google Cloud Platform that you're running, Kubernetes. Maybe it's one of the managed Airflow providers like Cloud Composer. Then you configure how many schedulers, how many workers, what is the setup of all the Airflow components. Set the CPU, memory, the resources used by Airflow components. If you run Kubernetes, you also need to set the number of nodes, the machine types, some configuration options of Kubernetes itself. And how you configure it, there's a configuration file for the instance configuration with Jinja style templating. This is an example. So you can see an example set up with a lot of Jinja placeholders for things like the node count, networking setup, like the Docker images used and so on. So this is how we set up the instance. And then next we set up the DAG. So we want to know what kind of workload we want to run in this Airflow instance. So how many DAG files do we want? How many DAGs? Like, do you want multiple DAGs in a single file, or do we want one DAG per file? How many tasks? What is the shape of DAGs? So do the tasks run concurrently all at once? Do they form a tree? Do they are they executed one after the other, or any other configuration? There's multiple of those. And then the operator type, do we want to run Python, Bash? We can easily configure more. So the simplest operators we have used for performance tests are just either operators that don't do anything or sleep for for a specific amount of time. It's easy to configure operators that would be like CPU heavy operators that simulate a CPU heavy task or a memory intensive one. This is fairly extensive. And then those two combined, meaning like the instance and the DAG, we configure the test suite. And the test suite can contain multiple studies, where a study is like an actual single test. We configure separate studies so that we can have a big common part of the configuration you see in the bottom, so that, okay, so we configure the Airflow instance, we configure many common things. In particular, there's the value file YAML, where all the common Jinja parameters are set. So this is common. And then we split to two studies, Airflow 2 and Airflow 3 at the top. This is what most of our tests looked like. And you can override those Jinja variables at various levels. Also, here we run 3 times each of the tests to get some averages. Okay, so once we have everything configured, we run a test, and this is the flow of a single test. So first, the framework prepares the instance. So either it creates a new instance, meaning I create a cluster, set up all the Airflow components, or if we set it up to reuse the instance, it connects to the existing instance, whatever we configure. Then all the DAGs are generated, uploaded to the instance, and the framework waits for everything to be settled, uploaded, ready to go, unpauses the DAGs, and the DAG runs begin. After some time, the DAG runs are finished. We stop the clock, collect all the metrics from Airflow, from the Airflow database, from the instance, write those metrics, and if we requested that in the test configuration, we delete the instance, meaning delete Airflow components, delete the cluster, and clean up. So this is the flow. And okay, so I said write metrics. What metrics do we write? First of all, we collect resource utilization metrics, CPU, memory, network usage of most of the major Airflow components, worker, scheduler, trigger, the database. And also we capture duration, so the total test time, that's one of the most interesting ones. And also individual DAG runs, task runs, all the times. We then get statistics from that. Okay, so how do we read the results after the test's finished? So basically, first thing you can look at is CSV files. They're written to disk. They can be uploaded to the cloud. You can open the CSV files with any software you want to use. But also we can export the data to BigQuery tables. This is something that's automatically done by the testing framework. And BigQuery, of course, makes it easy to query the results, display them, make dashboards, and so on. And we have 2 types of tables, both CSV and BigQuery. We have low-level metrics, like large tables with all the single metric values collected. And we also have a statistics summary table, which is more convenient to look at all the averages, minimums, maximums of resource usage of the times, and so on for each of the test runs. Okay, so now let's look at the results. So we have performed some tests, and starting with the baseline scenario. So this is a scenario we treat as a reference point. We set up Airflow on Google Kubernetes Engine, GKE, with 6 workers, 2 CPU and 7.5 gigs of memory, 2 schedulers with 1 CPU, 4 gigs of memory each, and a Postgres database. This setup is actually equivalent to a medium Cloud Composer environment. So there's a preset for medium, and this is the equivalent setup. But we tested it on a GKE cluster instead of Composer to make it more representative for others to be able to compare to. And what we compared is we compared Airflow 3.0.0 with Airflow 2.10.5, which are versions that were available to us when running the tests. And we run, in each of the tests, we run 10 DAGs in a combination so that the total number of tasks was 100, 1,000, 5,000, and 10,000. And all the operators we ran were no-op Python operators. Okay, so this why no-op? Why not doing sleeps? So we had a discussion. Do we want this to be more representative of real workloads? And so doing no sleeps gives us more results that more represent the actual Airflow instance performance. So we don't rely on on tasks performing anything. We just want to measure how Airflow itself performs. Okay, so let's look at the first chart. So this is the total test duration for the baseline scenario, comparing Airflow 2 and Airflow 3. And on the chart, Airflow 2 is in blue, Airflow 3 is in red. You can see that Airflow 3 performs around twice as fast, so the times are 2 times lower, which is good for Airflow 3. We also have a chart for the average task duration, which is surprising, and we did this test again and again, and we always saw the same results. So what you can see is that in Airflow 2, the average task duration is like almost always the same, regardless of the number of tasks, of total tasks. In Airflow 3, the more tasks we run, the longer it takes to actually run a single task. That's not intuitive why this is. So we dug deeper, and it turns out how we collect the metrics is on the chart here, you see that the yellow part is what is actually collected by the framework. So this is the task duration. Okay, so looking at the yellow part, Airflow 3 is slower. It takes more time. But it turns out there's a salary overhead, which in Airflow 2 is much bigger, and this is something that consumes a lot of time, and this is the thing that makes Airflow 3 faster in this case. Looking at the memory consumption of Airflow 2 and Airflow 3, of worker and scheduler, you can see that they're comparable. Airflow 3 using a bit more memory. And looking at the CPU, there's a much bigger difference. So Airflow 3 uses significantly more CPU. Okay, so is this bad? Actually, not necessarily. So if you compare that to the one of the first charts, where you see that the total test duration was twice lower in Airflow 3. So this means like in a unit of time, Airflow 3 performs twice as many things. So it consumes also twice as much CPU. So this is the explanation why CPU usage is higher in Airflow 3. And what it actually means is that Airflow 3 utilizes its resources better. Okay, so like summarizing the first part of the tests. So Airflow 3 overall performs better than Airflow 2. It utilizes resources better, faster to finish, using more CPU. And Airflow 3 uses a bit more memory. Okay, now let's look at a different test. What we now wanted to see is like how does the number of schedulers affect performance, the time to finish all the tasks. And again, we compared Airflow 3 with Airflow 2. The top chart is Airflow 3. And we tested 3 configurations with 1, 2, and 3 schedulers. So as you can see in Airflow 3, having 2 schedulers makes the test run twice as fast as having 1 scheduler. That's good. But adding the 3rd scheduler doesn't improve much. Okay, maybe that's interesting. However, when you look at Airflow 2, in Airflow 2, adding more schedulers does not make things faster, which makes Airflow 3 better again in this test. So why would you want to have more schedulers if they don't improve performance? Maybe for availability reasons, right? Because if a scheduler fails, another can take over. And this is a reason, that, like a valid reason to have more schedulers apart from performance reasons. And another test comparing setting the number of workers. So again, this is the taking the baseline scenario and changing only the number of workers to 3, 6, or 9 workers. And what you would expect is that having 6 workers makes everything run twice as fast as having 3 workers. In Airflow 3, that's exactly the case. In Airflow 2, not so much. And adding even 3 more workers increases performance, but again, not linearly to the number of workers. But this is expected. Like you can't add infinity of workers expecting to for the times to go down to 0, right? So this is something. This is a shape of the charts we expected, but as you can see, Airflow 3 again scales a bit better than Airflow 2. Okay, to summarize, we are working on the performance framework where we can show whether the performance improves or degrades. and the performance framework makes it possible to run various scenarios with various parameters being changed. And comparing Airflow 3 to Airflow 2, Airflow 3 is actually more performant than Airflow 2 and utilizes resources better. Also looking at like the specific tests with schedulers and workers, you can add more schedulers for availability reasons, for performance reasons, maybe not so much. And for the future of the framework, I'll hand it off to Michal.
Yep, so we want to get back to the story we started more than 2 years ago with the original AAP and framework. So at that time, it only supported Airflow 2. As you can see, we did run some tests with Airflow 3 as well, which means we did some developments in the framework to support Airflow 2 and Airflow 3 equally. So we want to submit these changes back to community, so stay tuned, they will be submitted shortly. And once we do so, I think it would make sense to actually integrate running these performance benchmarks to Airflow continuous integration. So we definitely should run them with every release when we produce new RCs to verify how that performance changes. But also we could be even more ambitious and integrate it in the daily runs so we can detect early any changes impacting the performance posture of Airflow. So that's brief plan for the next months. And now we can move on to Q&A. If you have any questions, we can dig deeper or double click on some of the issues.